Hi, and welcome to lesson 9.2 on the area of circles. So last we talked about circumference. This time we're talking about area of circles. So you can use what you know about circles and pi. Remember, pi was the distance around a circle divided by the distance across. It's that 3.14 number to help find the formula for the area of a circle. Okay, so we can use a compass to draw a circle and cut it out. So I'm not actually going to do this. I'm just going to walk you through what happens. So you get a circle and you cut it out. Fold the circle 3 times as shown to get equal wedges. So you fold it in half, you fold it in half again, and you fold it in half again. All right. Unfold and shade 1/2 of the circle. So unfold it, and you're shading in this half here. Then cut out the wedges and fit the pieces together to form a figure that looks like this. So when you cut them out, it looks like this. These 4 are right here, and the 4 white ones are right here. So now the point of this now is the base and height of it looks like a parallelogram. And if you remember how to take the area of a parallelogram, to take the area of a parallelogram, you multiply the length of the base times the height. And in this case, the length of the base here is half the circumference. Take a look at this. The circumference is all the way around, and this blue part is half that distance, so that's half the circumference is the base of the parallelogram, and this distance right here, that distance is the radius of the circle. So base B is 1/2 the circumference of the circle. Okay, I just mentioned that. Or pi times the radius. So and if you remember the circumference is 2 times pi times the radius. But if you have half of that circumference, then you would divide it by 2, and the 2's would cancel. So that's why half the circumference, I should have done that. Half the circumference is pi times the radius. So half the circumference is pi times the radius. And the height is the radius, or r. Okay, that's pretty easy. To find the area of the parallelogram, it's base times height. Okay, and so that means it's going to be base times height, or pi times the radius right here. So base times the height, which is the radius. And so that's pi times radius times radius. Pi times radius times radius. Well, the radius times radius, shorthand for that is radius to the 2nd power. Those two things mean the same thing. So the area of a circle is pi times the radius squared. That's the case every single time. So, I got some pencil marks here. Erase that. And on this, how can you make wedges look more like a parallelogram? So this kind of looks like a parallelogram. Parallelogram's more like, it has exactly straight lines like that. So how could you make that more like a parallelogram? Well, you can make the wedges smaller. So the base looks more like a straight line than it does curves. Because if you cut this into more pieces, it'll make it straighter. Okay. Next, here's our official formula. You have the radius of a circle. If you square that distance, which means multiply it by itself, and then you multiply it by pi, you'll have the area of the circle. And the area of the circle is how many squares fit inside of the circle. So when I have a circle like this, some awful looking circle, I realize it's an awful looking circle, but imagine that's a circle, and you make squares out of this. All right. Here's a square. 1, 2, 3, 4. Those are complete squares, but maybe this one isn't a complete square. But when you add it to this plus this plus this, you would get a complete square out of adding those 3 together. And here's a partial square and so on. So you can add partial squares, but in the end, you're going to have you're not going to end up with an exact number of squares. You're probably going to have a decimal at the end. So having said that, here's an example. Yeah, and remember it's given in square units. So a biscuit recipe calls for the dough to be rolled out into circles to be cut from the dough. The biscuit cutter has a radius of 4 centimeters. Find the area of the top of the biscuit once it is cut. Use 3.14 for pi. So we have our formula that was given to us up here. And we were told that the radius is 4. So we just plug that in. And I'll zoom in a bit here. So we're told that the radius was 4. Plug it in. 4 to the second power. That means 4 times 4, which is 16. And I had to do that first because you have to use the order of operations. In PEMDAS, I'll write that down here, PEMDAS. That's commonly used, parentheses, no parentheses, but then you have to do the exponents before you can multiply. And that's what I did. That little baby 2 right there is called an exponent. That means 4 to the second power. Not 4 times 2, it means 4 times 4, 16. 16 times 3.14, that pi, because now we can multiply that, means we got 50.24. And so the area is about 50.24 square centimeters. That's important. So compare finding the area of a circle when given the radius with finding the area of a circle when given the diameter. Okay, so the formula for the area of a circle uses I gotta zoom out here. Formula for the area of a circle uses the radius of the circle. If you're given the diameter, you have to first divide by 2 to get the radius. Because remember, the radius is half the size of the diameter. So why do you evaluate the power in an equation before multiplying by pi? Well, you must follow the order of operations, as I mentioned before, and evaluate the exponents before multiplying. I mentioned that. Okay, number 4. A circular pool has a radius of 10 feet. What is the area of the surface of the water in the pool? So they're not talking about the volume, how much water is in the pool completely, just on the surface. So what we have is our formula. Area is pi times the radius squared. That's taken from right up here. And I have pi as 3.14, and the radius was given to me as 10 feet, so I put 10 in there, and I evaluated 10 to the second power. That's 10 times 10, which is 100. And multiply 100 times 3.14. Well, that's super easy. When you multiply by 100, you just move the decimal 2 times to the right, and that's 314 feet. So there you go. And what I should do is, that's not just 14 feet, because we're talking about the area. So what I should be saying is 314 square feet. And this is an important detail. It's not 14 feet. It's not a distance. It's how many squares fit inside. 314 squares will fit inside of this pool, where each side of the square is 1 foot long. So it's square feet. And the shorthand for that is 314 feet. And you put a little baby 2 there, and that means area squared. And that is that part. What we have is next, 273, finding the relationship between circumference and area. Okay, you can use what you know about circumference and area of circles to find the relationship between them. So we have a circle. We got the radius right here. And start with a circle that has radius. Got it. And the radius is equal to the circumference divided by 2 pi. Remember, we have this circumference equals 2 times pi times the radius. This was from the previous lesson. And if I'm solving for r, I'd have to divide by 2 pi on both sides. And that would get these to cancel, and radius is by itself. So the radius is equal to, that's what's happening here. The radius is equal to circumference divided by 2 pi. Circumference divided by 2 pi. And so from here, and keep in mind, we're trying to find the relationship between circumference and area here. The area is pi times the radius squared. So area, in our formula before, earlier in this lesson, area is pi times the radius squared. So if area is pi, okay, pi, radius squared. but they didn't write radius squared here. And what they're doing is they're saying, well, if the radius is this mess right here, then the area is that mess squared, because that mess is a radius. So they just substituted. Instead of radius, they put this mess right here, and then they're squaring it with that baby 2 right there. Now, what they're doing is, in this point, they're actually squaring each one. And when you square this whole thing, you're multiplying c to the second power. Okay, c to the second power. Circumference to the second power. You got to multiply that 2 to the second power, 2 to the second power. Each element has to be taken to the second power. And then that pi gets taken to the second power. Each element they're doing right there. And then what they did here, from here to here, is they said, well, all this is being multiplied by pi. So I wrote that over here. Pi times c to the second. Okay, that's pi times c to the second. So really, this just kind of transitioned into the numerator, which is a legal move. You can do that. So that allowed us to remove the parentheses, kind of clean this up a bit. Pi times c to the second oh, this is actually 4, because 2 to the second is 4 right here. 2 to the second means 2 times 2, which is 4, and then pi to the second. Okay, so we got all that. Now, what we have is this. Pi times c to the second, pi times c to the second. 4 pi to the second. 4 times pi to the second right there. That pi to the second means pi times pi. And what we can do is we can cancel these right here. So what we're left with is c to the second over 4 pi. C to the second over 4 pi. That's what's happening here. And then now what we're doing is we are figuring out just c to the second. And c to the second, circumference squared. So what I would have to do is I have to multiply by 4 pi here, and multiply this by 4 pi here, and these would cancel each other out, and c to the second, which is here, equals 4 pi times the area. 4 pi times the area. See, wasn't that so simple? I know that was a lot of steps, but in the end, we come down with this statement. What is the relationship between circumference and area? The circumference of a circle squared. So the circumference of a circle squared is equal to 4 times pi times the area. 4 times pi times the area. And in the next problem, we're going to use this relationship here. So, does this formula work for the radius of 3 inches? So, I say yes. And right here, this relationship is getting used. Take a look at this. It's getting used right here. But I'm going to get to that in just a moment. So the area of the circle. The area of a circle with 3 inches. So pi, okay, there you go. Radius squared. Radius is 3, so that's 3 squared, which is 9. And you can switch the order of this. I guess I usually write the constant before, but anyway, 3, you can switch them at any time you want. And 9 times 3.14 is 28.6. Now I compare that to the circumference. And I use the one with the radius because I'm giving radius here. So 2 times pi times the radius. That would be 2 times pi. Maybe I'll put parentheses around everything to show that they're all being multiplied. And I decided to multiply 2 times 3, which is 6. And now I'm going to multiply by pi, because it really doesn't matter what order you multiply things. You'll still get the same number. So 6 times 3.14 is 18.84. So now I have my area. And I have my circumference. And so if I square this, it should be the same thing as 4 times pi times the area of that circle. So square it. And we have 18.84 squared is this mess. And then we have 4 times pi times the area, 4 times pi times the area, which was 4 times, I switched them. Oh, I don't have the whole thing. Yeah, this should have been, yeah. Oh no, I have the area right there. 4 times pi times the area, you multiply all 3, and you have that. So they are equal, and that is verified. And there you go. That's what you got to know about area of a circle.